This is a CCEA A2 Pure Maths question. We're going to look at question 4 here. This one's from 2022 and June. It's one on graph transformations. So let's take a wee look then at the question. The graph y equals f of x is sketched below, and we have this here. On the axis below, sketch the graph of y equals f of x plus 2 plus 1. Clearly identify the image of A and the location of the asymptote. So this then is a combined transformation. So we have two things that need to happen. That x plus 2 means everything moves that way, 2. And the plus 1 means everything moves up, 1. In this scenario, it doesn't matter which order you do them in. So the point A is moving back 2 and then up 1. So it's actually going to be then at the point 4, 0. So let's then kind of try and draw this in as best we can. It's quite an awkward one to draw. I'll kind of move it up here for you, and hopefully you can kind of see what's going on. So I think we're kind of like that. And then with our asymptote as well, which is kind of moved. So again, everything's been moved back 2. So this was at the point 5, and so the asymptote now is at the point 3. And then this here, point A, is at the point 4 there. So it's the coordinate then kind of 4, 0. Part 2. I have managed to lose. Give me a second. Here we are. Part 2, on the graph below, sketch the graph of y equals 2f of x plus 1. This one's a wee bit tougher, so we just need to be careful with what we're doing. So the 2f of x means it stretches twice as high, and then the plus 1 means it moves it up 1. But the way you do it is important, because if you do it the other way around, it's going to be wrong, and you just need to learn this off. This is the one, it's because it's affecting the y coordinates. So the first bit we need to do is we have got to do this bit here. So we're going to stretch it twice as much, and then we're going to add 1. So what effect is that going to have? It's all kind of going this way here. So we're going to stretch it up twice as much. So that's going to change from the 0.23 to the 0.26, as in across 2 up 6, and then up another 1. And then it's going to go up then to 2.7. This 5 here isn't going to be affected at all. So we can kind of draw this one on. So it's the same graph, only it's higher up. It's actually sort of stretched out, actually not quite the same graph. So that's crossing then at the 0.7. This new point A is at the 0.27. That's 2. And then the asymptote here hasn't moved. I should really be using a ruler here for this asymptote. And that then is at the 0.5. Part 3 is similar. The order of it is important, and you need to do it that way. So in this one here, that x over 2, that's an odd one there. So that was, say it was a 2x, I would squeeze it twice as close to the axis. But the 2 there means it moves twice as far away from the axis. And then the minus 1 means it goes this direction here. And in this one, you actually need to do the minus 1 first of all, and then stretch it out twice as far. So let's take a look then at what we're going to see. So what's going to happen? This is going to go 1 this way, and that is going to go then kind of from 5 to 6. And then it's going to stretch twice as far. Instead of being at 3, then it's going to be at 6. So my graph's going to look something like that. My point A, so what has happened to my point A? It has moved 1 this way, so it's a 3, 3, and then the x over 2 means it's doubled, so it's then going to be at 6, 3. That's the 0.6. That's the 0.3. And then what has happened then to the asymptote? So the asymptote has moved to the right 1, and then it's doubled, so it's gone from 6 and then gone to 12. And that's part 3.